Sample problem number 1. A skier starts from rest and slides 9 meters down in a slope in 3 seconds. In what time after starting will the skier acquire a speed of 24 meters per second? Assume that the acceleration is constant. So let's try to have our given. We have here 9 meters down the slope in 3 seconds. And this will represent the distance. Next, we have here 3 seconds. And then this will represent the time. And we have another here, 24 meters per second. This will represent our final velocity. Now, another thing that we should take note that we have also our initial velocity, and the value of that is 0 meter per second. Why? Simply because of this keyword as a skier start from rest. And then, what is the required? The required here is in what time after starting. So therefore, the required here is time. For us to further understand what we're looking on the problem, we have here the skier, and that is 9 meter down a slope. He finished it for around 3 seconds. Okay? Now, in what time after starting will the skier acquire a speed of 24 meter per second? So somewhere here in his travel, the final velocity must be 24 meter per second. So, what will be our equation? For this one, it is very useful for us to simply first find the number 1 acceleration. So, we could use these 3 formulas, but based on our given, we must have number 1, we have the distance, and we must also have the time. So the most useful equation from these 3 would be this one. And therefore we have now d equals to VIT plus AT squared divided by 2. Let's go now to our solution. Let's find first the acceleration. So in finding for acceleration, since d is equals to VIT plus AT squared divided by 2, should simply cancel out VIT because that is 0. And then we have now d is equals to AT squared divided by 2. Now, we should now derive for acceleration. So we could have 2d equals to AT squared. Deriving now for the acceleration, we simply have 2d over t squared. Okay, let's go now for our solution. For acceleration, so we have 2 times 9 meter divided by 3 seconds, and then square it. That will simply result as 18 meter divided by 9 seconds square, and that is 2 meter per second square. And so we have now our acceleration. Now, but the question here is, in what time after starting will the skier acquire a speed of 24 meter per second? Now, this time it is very useful for us to use this first equation, okay, wherein we have to look for time. Why? Simply because we need the final velocity as the variable, and as well as with the acceleration variable. And then what is the formula? We have Vf is equals to Vi plus AT. And then therefore we could now solve for the formula. We have here Vf minus Vi equals to 80. And then looking for time, we have Vf minus Vi divided by A. And then therefore, the value for that will be time. The Vf is 24 meter per second minus 0 meter per second divided by 2 meter per second square. And then therefore 24 divided by 2, that is 12 seconds. And that is the required time. A bus moving at a speed of 20 meter per second begins to slow at a constant rate of 3 meter per second each second. Find how far it goes before stopping. This time, let's try to identify the given, which is 20 meter per second, and this 20 meter per second will represent the initial velocity, and the final velocity would be 0 meter per second. Now, we have here 3 meter per second each second. So this is the other given. Now take note, this 3 meter per second each second could be denoted as 3 meter per second square as the acceleration. That acceleration is slowing down. So meaning to say that will denote a negative 3 meter per second square. So what is the required here? The required here is stopping distance. How far it goes before stopping. So that is the required. Now, so we could try to evaluate our three kinematic equation, which one will the best equation that we're gonna use. So we must have the initial velocity, we must have the final velocity, and we must have the distance variable, and then the acceleration variable. So the third equation is the best equation to use. So we write now d is equals to vf square minus vi square all over 2a. So our solution would be the vf square, that is simply 0 square, minus 20 meter per second square divided by 2 times the a, which is negative 3 meter per second square, and that is simply 400 meter square per second square divided by negative 6 meter per second square, and take note that is still negative, and therefore our answer is 67 meter. 7 meter. The speed of train is reduced uniformly from 15 meters per second to 7 meters per second while traveling a distance of 9 meters. Letter A, compute the acceleration. Letter B, compute how much farther will the train travel before coming to rest, provided the acceleration is constant. Let's try to write our given. The given here we have 15 meter per second. That would be the VI. And then 7 meter per second, that would be the final velocity or the VF. And then we also have a distance of 90 meter. And what are the required? For the required, for letter A, we have here acceleration, and for the second requirement, we have to compute the how much farther will the train travel before coming to rest. So meaning to say, we have the stopping distance. So we simply have now our equation. So the best equation that we could use, and obviously this would give us the d is equals to vf square minus vi square all over 2a. And computing for acceleration, we have to derive for a, and we have here 2ad equals vf square minus vi square. Deriving now for acceleration, that would be vf square minus vi square all over 2d. And therefore we have now acceleration, the value of vf square, we have here 7 meter per second square, that is our final velocity, minus 15 meter per second square, that is our initial velocity, divided by twice of the distance, and which is 90 meter. Solving now for acceleration, we have 49 meter per second square minus 15 square, that is 225 meter square per second square, divided by 180 meter, and therefore the acceleration now we have 0.98 meter per second square. Okay, next we need to find the stopping distance. So the solution for stopping distance, again, we have to use this formula, d equals to vf square minus vi square all over 2a. But this time, upon identifying our variables, the 7 meter per second, that would be the uh, initial velocity, 0 meter per second, and that is now our final velocity. The formula now for distance, simply we have vf square minus vi square all over 2a. By doing our substitution, we could have 0 meter per second square, 7 meter per second, and this is squared, divided by twice the acceleration, which is 0.98 meter per second square. Now, take note that our acceleration, by the way, is negative because it is slowing down. So I must use negative here. 0 meter per second square minus 7 meter per second and square it, that is 49 meter square per second square, divided by 2 times 0.98 meter per second square, and that would give an answer of 25 meter. So this is our final answer. What does this mean? This means that in order for the train to stop from the velocity of 7 meter per second to 0 meter per second at an acceleration of negative 0.98 meter per second square, it will travel 25 meter distance.